Selamat sejahtera, we are from DEM 4A. We're going to explain about semiconductor component which is silicon controller rectifier. My group member are Tan Yushun, Suvitra, Lee Zoya and myself, Kovisha Anavi. I will explain about introduction of semiconductor. Semiconductor are materials that externally can be conditioned to act as a good conductor or good insulator or anything in between. Common elements such as carbon, silicon, and germanium are semiconductors. Silicon is the best and most widely used in semiconductor. And now I will explain about function of semiconductor. A semiconductor can help control flow of electricity. The basic function of such a video is to switch on and off the flow of electricity as and which required. A semiconductor device can perform the function of a vacuum tube which hundreds of times its volume. Composed of semiconductor, which is elements semiconductor, are those composed of single species of atom, such as silicon, germanium, and zinc in column and selenium and tellurium in column of the periodic table. There are, however, numerous compound semiconductors which are composed of two or more elements. Now, I will explain about silicon controller rectifier. We know that the diode allows electric current in one direction and blocks electric current in another direction. In other words, the diode converts the AC current into DC current. This unique behavior of the diodes makes it possible to build different types of rectifiers such as half-wave, full-wave, and bridge rectifier. Those rectifiers convert the alternating current into direct current. The half-wave, full-wave, and bridge rectifier uses normal p-junction diodes, two-layered diodes. So, if the voltage applied to those diodes is high enough, then the diodes will get destroyed. So the rectifier cannot operate at high voltage. To overcome the drawback, scientists have developed a special types of rectifier known as silicon controller rectifier. And now I will explain about definition of silicon controller rectifier. A silicon control rectifier is a 3-terminal and 4-layer semiconductor current controlling device. It's mainly used in the device for the control of high power. Silicon control rectifier is also sometimes referred to as SCR diode, 4-layer device or transistor. It is made up of a silicon material which control high power and convert high AC current into DC current rectification. Hence, it is a name as silicon controller rectifier. And now I will explain about what is SCR, which is silicon controller rectifier. The term SCR stands for silicon controller rectifier, which is one of the most important members of the transistor family. It is more popular than one other transistor like SCS and DIAC. That some people even use the words transistor and SCR interchangeably. So next time when someone says just transistor is general, then they are referring to the SCR. SCR are constructed from silicon and are most commonly used for converting AC current to DC current rectification. Hence, the name silicon control rectifier. They are also used other applications such as regulations of power inversions. The SCR have an ability to handle high value of current and voltage, hence they are used in most of the industrial application.
Hi, I'm Svitra. I'm going to explain about SCR symbol. The symbol of the SCR will be similar to that of the diode. Additionally, it has a gate terminal as shown below. The SCR is an unidirectional device that allows the current to flow in one direction and oppose it in another direction. SCR has three terminals, namely anode, cathode, and gate. It can be turned off and on by controlling the basing condition or the gate input. Now I'm going to talk about construction of SCR. The SCR is a 4-layer semiconductor device that forms NP, NP or PN-PN structure. which eventually forms three junctions J1, J2 and J3. Among the three terminals of the SCR, the anode is a positive electrode. It will be on the P layer and cathode is a negative electrode. It will be on the N layer of the SCR. The gate acts as a control terminal of the SCR. The SCR construction image is shown below. Here are the SCR construction image. The outer P and N layers where the two electrodes are placed will be heavily doped and the middle P and N layers will be lightly doped. The gate terminal will be connected to the P layer in the middle. The SCR are constructed with three different types: planar type, mesa type and press pack type. Now I'm going to explain how SCR works. To understand the SCR working principle, we have to look into the different ways it can operate. Depending on the polarity of the voltage applied and the gate pulse given to the SCR, it can operate in three different modes such as forward blocking mode, forward conduction mode, reverse blocking mode. Explaining about forward blocking mode. In this mode of operation, the positive voltage is applied to the anode and the negative voltage applied to the cathode. There will not be any pulse applied to the gate. It will be kept in the open state. Once the voltage is applied, the junctions J1 and J3 will be forward basted and the junction J2 will be reverse basted. Since J2 is reverse basted, the width of the depletion region increases and it acts as an obstacle for conduction. So only a small amount of current will be flowing from J1 to J3. When the voltage applied to the SCR is increased and if it reaches the breakdown voltage of the SCR, the junction J2 gets depleted due to the avalanche breakdown. Once the avalanche breakdown occurs, the current will start flowing through the SCR. In this mode of operation, the SCR is forward basted, but there will not be any current flow. Diagram below show forward blocking mode of SCR. Now I'm going to explain about forward conduction mode. The forward conduction mode is the only mode at which the SCR will be in the on state and will be conducting. We can make the SCR conduct in two different ways. One, we can increase the applied forward base voltage beyond the breakdown voltage, or else we can apply a positive voltage to the gate terminal. Below shown the diagram. When we increase the applied forward base voltage between the anode and cathode, the junction J2 will be depleted due to the avalanche breakdown and the SCR will start conducting. We are not able to do this for all the applications, and this method of activating the SCR will eventually reduce the lifetime of the SCR. If you want to use the SCR for low voltage application, you can apply a positive voltage to the gate of the SCR. The applied positive voltage will help the SCR to move to the conduction state. During this mode of operation, the SCR will be operating in forward base and current will be flowing through it. When we increase the applied forward base voltage between the anode and cathode, the junction J2 will be depleted due to the avalanche breakdown and the SCR will start conducting. We are not able to do this for all the applications, and this method of activating the SCR will eventually reduce the lifetime of the SCR. If you want to use the SCR for low voltage application, you can apply a positive voltage to the gate of the SCR. The applied positive voltage will help the SCR to move the conduction state. During this mode of operation, the SCR will be operating in forward base and current will be flowing through it. Explaining about reverse blocking mode. In the reverse blocking mode, the positive voltage is applied to the cathode and the negative voltage is given to the anode. There will not be any plus given to the gate. It will keep as an open circuit. During this mode, the junctions J1 and J3 will be reverse basted and the junction 2 will be forward basted. Since the junction J1 and J3 are reverse basted, there will not be any current flowing through the SCR. Although there will be a small leakage current flowing due to the drift charge carriers in the forward base junction J2, it is not enough to turn on the SCR. These are the diagram of the reverse blocking mode of SCR.
Good morning, everyone. I am Tan. I will discuss about VI characteristics for SCR. The VI characteristics for the SCR are obtained by operating the SCR in three different regions, named forward blocking regions, forward conduction regions, and reverse blocking regions. Below show a diagram about VI characteristics for SCR. When the SCR is operating in the reverse blocking mode, there will be small lagging current flowing in the reverse direction for the SCR, which is mentioned as the reverse lagging current in the graph. The reverse lagging current will be located at the negative quadrant for the graph. Now if you apply positive voltage to anode and negative voltage to cathode, the SCR will start operating in the forward blocking mode and a small leakage current will be flowing through the SCR in the positive direction. Hence, the curve starts rising to a certain level in the positive current for the graph, which is mentioned as the forward lagging current. Once the graph reaches a certain voltage level called the breakdown voltage, for if the gate current Ig is applied to the SCR moves to the conduction mode and a high amount of current starts flowing through the SCR. The current flow is represented as the flowing conduction in the VI curve. The gate current applied are mentioned as Ig1, Ig2, and Ig3. Higher the F, 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 the high gate current, faster the SCR goes to the conduction state as Ig3 less than Ig2, Ig2 less than Ig1.
Hello guys, I'm Lee from DEM 4A. So now I want to explain SCR application. From converter circuit to control circuits, SCRs are used in a wide range for application. It is not possible to discuss all the transistor application, but basically they are used to control the current or voltage across a device. For example, let's consider an example where SCR are used to control the spin of a motor.
The above circuit diagram of SCR shows the arrangement for controlling the speed of a DC motor using the SCR. The motor will be having two windings, namely field winding and armature winding. By controlling the currents given to the armature winding, we can control the speed of the DC motor. The armature winding for the motor is connected to an AC supply through a transformer and two SCRs connected in parallel with one another. During the positive half cycle of the AC supply, the SCR1 is forward biased and start conducting. If the gate plus is applied, the current to the armature winding will be flowing through the SCR1. Similarly, during the negative half cycle of the AC supply, The SCR2 is forward bias and SCR1 will be reverse bias, and hence the SCR1 going to the off stage. When the gates plus is applied to SCR2, it starts conducting. By varying the trigger plus given to the gates for the replacive SCR, we will be able to control the impulse given to the DC motor, hence it controls the speed of the motor. So this is function of SCR. It's used for power control and switching. It's also used for DC circuit breaker. SCR help over voltage protection. Besides, there's power circuits. SCR can battery charging regulator. After that, SCR also function for zero voltage switching. SCR also used for AC power control with solid relays. Last but not least, SCR can trace 0 points switch application. Okay, this is advantage and disadvantage for SCR. Advantages: the silicon controller rectifier SCR can handle large voltage, current and power. It can be protected with the help of fuse. It is easy to turn on. The triggering circuit for silicon controller rectifier SCR is simple. It is simple to control. Its cost is low. It is able to control AC power. Disadvantage: the silicon controller rectifier SCR is unidirectional device, so it can control power only in DC power during positive half cycle of AC supply. Thus only DC power is controlled with the help of SCR. In AC circuit, it needs to be turned on each cycle. It cannot be used at higher frequency. The gate current cannot be negative. Okay, that's all for my groups. Thank you. Hope you all guys learned about SCR gains knowledge. Thank you.